these are not going to be very long notes, but I got to talk about this. We're going to talk about our learning target, our success criteria. Our learning target is that we can make measurements. We're learning to make measurements. And you guys probably know how to make measurements pretty well. But something in science that we have to count for is something called precision. What does precision make you think about? Any ideas, any words you might associate with precision, or any kind of definitions of precision you might know of? What is it? Precise, yeah, precise. Anything else we have? Like, what does that mean? Precise. Specific. Any other words you guys can think of? Accurate. Any other words that come to mind when you're thinking of precision? Exact. Anything else? Okay, so our success criteria, I'm going to go ahead and write this down here. Our success criteria is I can make accurate measurements. With the correct level of precision. Okay, so these learning targets that we have, they kind of give us an overview of what we're learning to do. And then the success criteria makes it specific. So you always want to think of this success criteria as the lesson's going on. Keep checking back every 10 minutes. Can I do that? Can I do the success criteria? Can I make accurate measurements with the correct level of precision? Yes? No? How do I feel? What do I got to do to get there? All right. So as you can see by the title, today's measurements are going to be about volume. All right. So we're going to talk about finding the volume of a substance or an object. Okay. So the first thing I want to talk about is liquids. All right. So with liquids, first of all, the tool we're going to use, usually with liquids, we use a graduated cylinder. You guys have seen these before. And the units, never forget the units. We're going to use our milliliters. We could use liters for larger volumes, but we'll be using milliliters. So you'll have to forgive my drawings. You'll find over time that I make really poor drawings. But let's say this is a graduated cylinder. Okay. And I have some liquid in here. All right. And this is not a very good graduated cylinder. The reason why we use graduated cylinders is because they have so many marks on the side of them. Now this particular graduated cylinder that I have, obviously down here we have a 0, and then up here there's a mark that says 100, and that's it. Okay, so that wouldn't be a very good graduated cylinder to use, because usually we like to have a lot of marks. But this is how precision works. Okay, so we look at the marks that we have on the graduated cylinder. Okay, and I say to you, I ask you this question: can you tell? Oh, real quick. When you get this little dip in the liquid here, right here, that's called a meniscus, okay? And so the meniscus is a dip in the liquid. And so for the sake of keeping all our measurements the same, measure the lowest part of it. Okay, always measure the lowest part. Okay, so can you tell for certain that that volume of liquid in there is between 0 and 1,000 milliliters? Raise your hand if you think that volume is between 0 and 1,000 milliliters. Okay, so I'm seeing all hands up because everybody says, yeah, that's definitely between 0 and 1,000 milliliters. Raise your hand if you can tell me with pretty good confidence that that measurement is between 0 and 100 milliliters. Okay, so here's 0 down at the bottom. There's 100. I would definitely say that that volume is between 0 and 100. How many people in here could confidently tell me that that measurement is between 10 and 20 milliliters? 30 and 40? 40 and 50? 50 and 60? Okay, so we're uncertain a little bit at this point, and that's good. In the measurement, there's going to be an uncertainty. Okay? When we make the correct measurements, we are always going to estimate our last spot. What does estimate mean? Kind of guess, yeah. We kind of guess. Okay, so if I accurately record this measurement using the rules we use in science for measurement, I can say for certain it's between 0 and 100. Okay, so now what I'm going to do is I'm going to estimate where I think it is. To me, it looks like it's about in the middle. So what is about in the middle of 0 and 100? 50. And that's an estimate, but that's what I'm going to write for my measurement. Okay? And I always include units, so I would say 50 milliliters, and that would be the correct level of precision. Okay? So really what you do is you look at your marks. Like this particular graduated cylinder is marked in hundreds, apparently. And you go down a step from there. So my estimate is going to be the tens place. All right? Like we couldn't say for certain this is between 50 and 60 or 40 and 50. It's kind of hard to tell, right? So that's kind of a guess, that 50. All right? Now let's look at another graduated cylinder. Okay, now this one is marked every 10 milliliters. Okay, and then I have a liquid in here that goes to about there. All right. Okay, so now recording this measurement, we can accurately say, without guessing, it is definitely between what and what? It's between 20 and 30. So we definitely know that it is 20-something. That's not a guess. I know it's 20-something. I can tell that for sure by looking at it. But now, are there any smaller marks so that I can tell it exactly? There aren't. Okay, so my next number has to be a guess. All right? And this is going to be our last digit. So If it was right in between them, so here's the lowest point right here, comes to about there. If it was right in between 20 and 30, what's right in between 20 and 30? 25. Does it look like it's right in between perfectly? Does it look a little higher? So I might say 26. Okay? Somebody else might say 25, and that's okay. Somebody might say 27. That's okay because that last digit's an estimate. And anybody who's had this lesson would know that when they read this measurement of 26, they know that there's some uncertainty right here in this number. Okay? Because they know that's how you measured it. Okay? One more graduated cylinder. And this graduated cylinder is marked in ones. Okay? Okay, and our liquid here, let's say, is right about there. Ooh, I'm going to bring it a little lower. Okay. All right, that one. Can we tell that that's between 1 and 2? Can we tell that it's between 2 and 3? I would say so. Okay, if I'm looking at, we always want to look at these flat. And the lowest point is probably coming right about, almost like right at 2, okay? But I would say this is 2. All right. Ooh, always put the units, Mr. Dodds. Always put the units. Okay? But now that I can tell it's at 2, I'm going to estimate one spot further. But it looks like it's right at 2, so what am I going to put? I could put 2.1, sure. That would be okay. What else can I put? I could put 2.0. I could put 2.1. Somebody else might have even thought it was 1.9, okay? But again, we can see the ones place. That is the lowest mark on this graduated cylinder. I can see the ones place, so I'm always going to estimate one spot further. And that's how we do the measurement with the correct level of precision, okay? So we can do liquids, we can do in graduated cylinders, okay? Now let's talk about solids. And I'm going to call this a regular solid. Okay, and the reason I'm going to call it a regular solid, I don't know if I can do this, is because it has square measurable sides. Oh, not too shabby. Not too shabby, okay. All right, so we have a regular solid. So this is another way to find the volume. Let's say this side, call this the width. Length, width, and height doesn't really matter. You just always want to make sure you have 3 different sides. So I'll call that the length, or width, sorry, and I'll call that 2 centimeters. I'll call this the height, and I'll say that's 2 centimeters. And then I'll call this the length, which we'll say is 3 centimeters. Okay? So to find the volume of a regular solid, all we do is length times width times height. All right? We multiply the 3 things together. So in this case, it would be 2 centimeters times 2 centimeters times 3 centimeters. And so that would be 2 times 2 is 4 times 3 is 12. So 12. And our units in this case, since I did centimeters times centimeters times centimeters, is going to be centimeters to the 3rd power, which we also call centimeters cubed, or we call them cubic centimeters. Sometimes, if you ever watch a medical documentary or a medical show, they might call them cc's. Okay? So that's how you do a regular solid. So what about an irregular solid? Okay, so an irregular solid something that doesn't have three nice little easy sides to measure. This little pile of, little clump of whatever it is, okay? How am I going to find its volume? So we do this by a method called displacement. When they find the volume of car engines, if anybody likes cars, they find that volume by displacement. And this is how you do it. For us, first of all, it's got to be kind of a small object, because what we're going to be doing is we're going to be putting it in a graduated cylinder. So what I do is I take a graduated cylinder, try to make this easy here. Let's say this is by tens. And I'm going to put a set amount of liquid in there. Like I might, and I want to try to make it an easy number to read and understand, an easy number to do math with. So if I had this particular graduated cylinder, then maybe I would try to make it so that my volume was like right at 20, okay? So that volume, I know it's right at 20, which, by the way, I would put a point on there to show that that 0 is significant. So that's my starting. I'll talk about significant digits later. I just want you making measurements for now. All right, but we would call that 20. We don't estimate down in the tens place. The lowest mark on here, I'm sorry, we don't estimate down to the tenths place. The lowest mark is the tens, so my estimate spot would be the ones. That's going to take a little getting used to. If you're not getting it yet, you'll get it the more you practice. But now what I'm going to do is I'm going to take that clump of whatever it is, and I'm going to put it in that graduated cylinder. And so now if I put it in the graduated cylinder, the water is going to go up. Yep. So let's say I put that clump of stuff in here, boom, like that. And now let's say the volume goes up to here. All right. So it started at 20. I put this irregularly shaped object in there, and the volume went up to 30. So what is the volume of the object? Okay, so my volume after is 30 milliliters, and my volume before was 20 milliliters. Therefore, the volume of the object must be 10 milliliters. So there are three ways that we can find volume. So now I'm going to give you this worksheet, and we're going to practice this today. Okay, so I'm going to do a couple of examples of each type with you. So here is your worksheet, all right? And so the very first graduated cylinder, it looks to me like it's right about there. Would you guys agree? Okay, so first of all, can we tell for sure, are there markings that tell us that this measurement is between 20 and 30? Okay. So it's going to be 20 something. We know that for a fact. Are there smaller markings than that? There are. We have 1, 2, 3, 4. It takes 5 marks to get to the next one. Okay, so we got to pay attention when we look at this. What does each one of those marks represent? Okay. If it was 1, then that means it's 20, 21, 22, 23, 24, 30. Does that make sense? No. What if it's by 2s? 20, 22, 24, 26, 28, 30. That makes more sense. So it's by 2s, all right? So we've established that the tens place, all of those are marked. All right. The ones place, are all of the ones marked? For example, can I see 21 exactly on there? Can I see 23? I can see 22 and I can see 24 and 26 and 28. But I cannot see 21, 23, 25, or 27, or 29. All right? So that means if I can't see every mark for the ones place, I'm going to estimate that ones place. So where do we think this is at? Is it right at the second mark? I can say fairly confidently that it's at that second mark. Might not be exact, but again, this is an estimate. So what would I call this measurement? Okay, 4, right? Because they're each worth 2. And always write the units. Get used to always writing the units. Okay, every time you write down a measurement. Okay. Maybe we'll do one more, because look at this. All right. So this time, looks like it's about there. So can I tell it's between 5 and 10? Okay. I can see on this one, I can see it's marked every 5. I can see that it has an individual mark for each one. I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can see all of those. Can somebody answer that for me? Thank you, Kayla. All right. So I know the ones place here. I can tell that that is between what? What numbers would you say it's between? Between 8 and 9? I agree. So it's going to be 8 something. It's going to be 8 point something, and this is where I'm going to estimate. Judging on here, is it about halfway? If it is, it'd be 8.5. Is it a little lower than halfway? Maybe a little lower than halfway if I'm measuring the lowest part of it. Maybe I'll say 8.3. Maybe you say 8.4. Maybe you say 8.5. Maybe you say 8.2. We're all right. Okay? The main idea when these get graded on a quiz is that you are going to the right decimal place. Okay? Yeah, I look for it to be fairly accurate. Like if you put 6.2 here, that wouldn't be correct. All right, but 8.3 is acceptable, 8.2, 8.4, 8.5, 8.1. All of those would be acceptable. Okay? So I'm going to let you guys finish the rest of those, and then we'll practice on the back side tomorrow. Okay?